All right, so new chapter. Chapter 4 here is going to be all about working with triangles. So starting with here, our lesson 4.1 is we're just looking for, can we prove that figures are congruent? So the kickoff from last time, we did write an equation of a line that's parallel to y equals negative 4x plus 3 and goes through the point 1, negative 2. So already have here, m is going to be negative 4 because it's going to be the same slope as what that other one is since it's parallel. And we're going to use this point. So y minus y of our point is 2, so plus 2, or it's a negative 2, so it makes it plus 2, equals negative 4, parentheses, x minus x of our point is 1. To get into slope-intercept, we would distribute the negative 4 in. So y plus 2 would equal negative 4x plus 4. We would then subtract the 2. So y would equal negative 4x plus 2. So, way to check it, negative 4x's, we're good there. We're plus 3, we're plus 2, so we're going to be parallel. We don't want our y-intercepts to be the same. All right? So, if we look at these same figures here. So if I take the figure and I slide it over, it's really doing nothing to it. So those would be the same. If I take the figure and I flip it over, again, not changing anything about it, it's going to be the same. If I take it and I turn it, besides the fact that it's cut off here, but if this was to continue out, it'd be the same figure. So if we slide it, we turn it, we flip it, it does nothing to the figure, but these would be congruent figures then. There's nothing different to it. So if you notice here, we haven't changed the size in it. We also haven't changed the shape of it. And that's going to be the main thing. When we're congruent figures, the sizes have to be the same, the shape has to be the same. So with those though, we can say congruent polygons then, if we know the two shapes are the same, they're going to have congruent corresponding parts. So think the sides that match up would be congruent, and the angles that would match up would be congruent. So if I look here, this bottom side and this bottom side would be congruent, just like this side and this side would be congruent. This side would, this side, this side. These two angles would be, these two angles would be, these two angles would be, these two angles would be. So the parts that match up, those angles, those sides, are going to be congruent as well. So if we think about a triangle, now we could do this without even drawing this out. Because remember, when we name shapes, we name it in order. So it goes T, J, D for this triangle, R, C, F for this triangle. So congruent sides would be TJ and RC. Another set would be JD and CF. And lastly, TD would be congruent with RF. So notice how if it started with the T and the R match up, the J and C match up, the D and F match up. So TJ is going to be the same as RC. TJ and CR wouldn't be congruent. We could, well, it would be, but we can't say it that way because T matches up with the R, the J matches up with the C. So what I'm getting at is order matters here. It would be wrong to say TJ equals CR. Even though it's the same segment and they would be congruent, it's just bad form to do that. So when it comes to angles, same idea. So T and R, since they are first, they're going to be the angles that match up. So angle T is congruent to angle R. J and C are second, so those are the angles that match up. So angle J is congruent to angle C. D and F, same thing there. Angle D congruent to angle F. So order matters with these. That's why we pick, okay, when we're writing this congruent statement, if we go T, J, D, that means T and R, J and C, D and F are the ones that match up, that are corresponding. So even when you're writing these statements, so this triangle congruent to this triangle, it has to be written in the right order or it doesn't work. Now, here's where congruent parts could help us solve some things out. So we're dealing with two shapes here. We're going to try to find the measure of angle B. Right now, B is out here by itself, and we have no other measurements with it. However, this identical shape on the other side has these different angle measurements that we're going to be able to find. Now, B and E is what would match up. E we don't have an angle for, so we can't just look and go, oh, well, it's this. So we got to do a little bit with it. Now, with this one here, we have 1, 2, 3, 4, 5 sides. 1, 2, 3, 4, 5. So if we think about it, 5 minus 2 times 180, which this is 3. 3 times 180 is 540. All of these here should add up to be 540. So we'll be able to find measure of angle E that way. So if I start with E, measure of angle E plus the next one down, S, we know is 88. Next run around would be 90. Next one we hit again is 90. And then we're 132. We know that has to be 540. So if I take 540 and I subtract out 132 and then subtract out 90, subtract out another 90, and then subtract out 88, I'm going to be left with the measure of angle E is 140 degrees. So if E is 140, B is what matches up with it, so that has to be the measure of angle B as well. Now the other way we could look at this is if S is 88, D here could have been 88. W, if we know C is 132, W would be 132. We have our 90s, we could solve it the same way and get B this way too. So a couple different ways we can use that, knowing that congruent parts are going to be congruent. Now, by definition, two triangles are congruent if they have 3 pairs of congruent corresponding sides. So the 3 sets of sides that match up have to be congruent each pair. We also have to have 3 pairs of congruent corresponding angles. So the angles that match up, those 3 sets, each set has to be congruent. So you're going to get shapes like this. So by definition, we have to have 3 sets of congruent sides. So we're going to look, do we have 3 sets of congruent sides? Well, we have AC is congruent to EC. Notice how, again, I did A to C, so I did E to C, not C to E, okay? Because we have the marks. Okay? I know AB is going to be congruent to ED, and because they're both 3. So equals 3. My last set is BC here. It would be congruent to DC because they both equal 4. So I have 3 sets of sides, so that fits that definition. Now we're going to look at angles. I know angle A is congruent to angle E, again by the marks. They both have a single tick mark, so I know they're the same. I could say angle B is congruent to angle D because they're both right angles. Right angles are 90, so they're both going to have the same measure. Lastly, now I'm not just going to say angle C because angle C could be this one, could be that one, could be that one, could be that one. So if there's multiple angles going on at a specific point, you have to use the 3 letters to designate that angle. So I would say angle ACB is going to be congruent to angle ECD. So again, it's important. A and E match up, B and D match up, C and C match up. Well, there's no marks here. We don't have any measures. Why are those 2 congruent? Well, those 2 are vertical angles. Vertical angles is one of those where we can look at and we can see that, hey, if these are vertical angles, they have to be congruent by that vertical angles theorem. So I'm going to put vert angles. So why they're congruent. So we have 3 sets of sides, 3 sets of angles. So we can say triangle ABC is going to be congruent to triangle. So we did A, so we have to start with E. Then went to B, so we have to go to D. And then we ended with C, so we ended with C. So again, important that you write it in the designated order. Otherwise, it's really not true that they're congruent if they don't match up. All right. Now, as we go through this chapter, we're going to find other ways that we don't have to find all 6 things being congruent. We're going to be able to find ways knowing less, but for right now, we're sticking with the definition part of it. So next we have Theorem 4.1. Theorem 4.1 says that if 2 angles of one triangle are congruent to 2 angles of the other triangle, so if we have 2 sets of angles that are congruent, then we know the third set is going to be congruent as well. Well, it makes sense because each triangle, no matter what, is going to add up to be 180. So if we have 2 sets that are the same, we have 2 angles that are the same measure, the last angles have to be the same measure then. That's where that theorem's coming from. So we're going to prove that these 2 triangles are congruent, knowing that PQ is congruent to PS, QR is congruent to SR, QR and QS, QPR and SPR. So I'm going to start with my given, and for right now I'm going to circle this and draw the arrow down, and my reason is given. So we're going to go through and we're going to start checking this. So PQ, PS. So PQ, PS, we have our single tick marks, so that one's covered. QR and SR. So QR, SR, we have our double ticks, so those are covered. So we have 2 sets of sides right now. Keep that in mind. Now we have angles. So Q and S are congruent. And now notice here, P has multiple angles, so they use the 3 letters. So Q, P, R, so this inside angle would be the same as SPR, this other angle here. So we have 2 sets of sides, 2 sets of angles. So to prove this congruent by definition, we need 3 sets of sides, 3 sets of angles. So we're going to need one more side, one more set of sides, and one more set of angles. So this is where this starts getting fun. Because if looking here, we have this side, this side, this side, this side. They share PR. So we can say PR is congruent to PR by reflexive. If it's congruent to itself, it's reflexive. So we can see here, they're the same line. They're sharing that same side. So this is a visual one that we can say, yes, we know this set of sides are going to be congruent because they're the same line. We can see that. So we have our 3 sets of sides now. So now we need our third angle. And so number 3 is going to be angle QRP. Is going to be congruent to angle. So we start with Q, went down to R, went to P. So the other side would be SRP. And that's by that theorem 4-1. If we know we have 2 sets of angles that are congruent, the third set is automatically congruent. So now we have our 3 sets of sides, 3 sets of angles. So now we can do our proof. Triangle ABC is going to be congruent to triangle EDC. And that is by definition. So, getting more into 2-column proofs again. This is going to be a lot in this chapter, but they're going to be like this, where look for these easy sets of sides, look for an easy set of angles, and you're going to be able to fill it in. So, let me know if you have any questions. Otherwise, until next time, we'll talk to you later.